of ingredients, kind of like a recipe. How shall we put these ingredients together? The first thing we'll need is space. Now let's see, what can we use for space here? This large Ziploc bag will do. Let's catch some space here. The main ingredient in comets is water. Comets are not liquid, however. In space, that water is in solid form as ice. Liquid water is absolutely critical for life. More than half of our body weight is water. I'll pour out some water here. Some think that around a third of Earth's water came here when comets smashed into our planet billions of years ago. We've also learned that comets contain carbon, and so we'll add some charcoal, which is mostly carbon. You may also use graphite or, crush up the nearest diamond ring. Graphite and diamonds, like charcoal, are both forms of carbon. Perfect. The tail of a comet consists of all kinds of gases, sand, and dust. Energy from the sun pushes this gas, sand, and dust away from the comet to form a long stream that points away from the sun. If you've ever seen a meteor shower filled with so-called shooting stars, those are caused by sand and dust discarded from a comet. Before they hit our atmosphere, we call them meteoroids. And most meteoroids are no larger than grains of sand. They burn bright hot as they fall through our atmosphere in a beautiful display we call a meteor shower. Almost all of them burn up completely and never reach the ground. Let's add some meteoroids to our comet. Let's do 2 big scoops. Okay. Look at that. This proto-comet is looking pretty dirty though. I think it's time to clean it up with some window cleaner. Now this is not just any window cleaner though. The active ingredient in this one is ammonia, or NH3. Ammonia is a chemical made of nitrogen and hydrogen, 2 elements that are essential for life. Comets contain the building blocks that are important for life, like ammonia, so we shall use this window cleaner to represent all of those organic compounds. Let's do a few more. What secrets lie in this murky, gallon-sized Ziploc bag? Ooh, it sloshed a little bit there. And there's our comet. Wait, that doesn't look like a comet. We have a problem. Liquid water doesn't exist in space. I need to find a way to freeze this. We could put it in a freezer, but I don't have all day. I know the fastest way to freeze our comet. We'll use dry ice, which is extremely cold and made of frozen carbon dioxide. Dry ice does not occur naturally on Earth, but it's very common in comets. But first, I must put on my safety goggles and my thermo-insulating gloves to get some out of our container. Okay. Notice how it doesn't melt, but turns straight into a gas from a solid. That's called sublimation. Now, dry ice is negative 109 degrees Fahrenheit. Let's see how fast it can freeze our comet. Wow, it's getting a little spooky. It's like a potion. It's making me want to laugh. Look at that. Wow. Wow. I'm a mad scientist. Look at that. Ooh, it's starting to clump together a little bit. Now, with the force of gravity stimulated by my immense muscle strength, I'm very strong. Drum roll, please. Okay. Here we can see our carbon, our charcoal that we put in. We see our dry ice, our carbon dioxide, and water. Let's see if we can find some of our meteoroids. This is a pretty good one. Here's some meteoroids along here. Can you see those? Look, it's saying something. Listen. Very cool. This model comet was easy to make in our Comet kitchen. I'm going to set all of these aside now. But how did real comets form in space? We must travel back in time to find out.